Okay, this time we will see this question, min cost of climbing stairs. So again, this is an easy type of question, and let's see what is written here. You are given an array of integer cost, where cost of I is the cost of ith step on that staircase. So what it means, suppose you are climbing a stair, so the cost of that stair, you have to pay that cost first, and then you can climb on that stair. Okay, you can either start from once you pay the cost, you can either climb one or two step. So means you can either climb one or two step, but you have to pay the cost of that step also. Okay, you can either start from index 0 or index 1. So very good. So return the minimum cost to reach at the top of the floor. Okay, so first example is this, that you have cost is equals to 10, 15, 20. So if you start from 15, you can directly reach at the top and your cost will be minimum. Suppose if you start from 10, then you can either start from one step or you can go two step. Okay, so if you start take one step after 10, that will not make sense because that will maximize your cost will become 25. Yes, and if you take two step after 10, your cost will become 30. That is also not good, so our answer will be 15. And again, this example is also same like this. So what will I do in this problem? See, you are here, just see this, you are here and you have to climb there. Yes, from here to there. So what will you do? Suppose you do only have, so let me write index first as well. 0, yes, 0, and its index is 1, its index is 2, and let's write index of this, but we don't need this. So suppose you climb, you want to climb here. So what is the minimum cost you will need to pay? So if you want to climb at first stair, you will need to pay 10. Okay, you will need to pay 10. If you want to climb here, so suppose you have only a stair of 10. I'm breaking it down. See, DP is what? Dynamic programming is breaking down your big problem into small sub problems. So I am breaking it. See it carefully. So suppose my staircase is this only and I have to reach here. I am breaking it. I am here. I have to reach there. And this is my 0th index and value at 0th index is 10. Okay. I am breaking my problem into small sub problems. See, this is the smallest part of my problem. So if I want to reach here to here, how much cost will I pay? So suppose my staircase is this only. So if I want to go at first staircase, I really need to pay 10. Minimum cost that I will pay is 10. Okay. And suppose I want to reach here, I can either move one step or two step. Suppose my staircase is this only. Uh, Let me rub it. Yes. Suppose my staircase is this. Okay. I do not, this is my top only. So I'm starting from this. So if you want to start from 10 index, you only have 10. So you will have to pay this cost. Okay. So that's why the minimum cost for 0th index is 10. Now you have a stair of 15 as well. 15 as well. Yes. Now you have to reach here. See, this is the smallest sub problem now. Now you have to reach there. So what will you do? For this, you will need to pay 10. For this index, you will need to pay 15. So if you are climbing, what will you choose? I will choose this 10 first, and then I will climb two step. So what we will do? We will try minimum cost up to here. Okay, minimum cost between. See, I'm writing the formula. Suppose this is my function, so minimum cost, so I this index is 2. Okay, this index to climb here is 2. So minimum cost at 2 is equals to wait, let me write it. Minimum cost at 2 is equals to min of what? Minimum cost of f of 2 minus 1 plus f of 2 minus 2, that is 0. Okay, so you can write like this as well. Wait, yes, minimum cost of 2 minus 2. Okay, so minimum cost to reach f of 2 is minimum of both. See, minimum of both. What is the minimum in both of them? So 10 is the minimum. So our answer is 10 here. Okay, and suppose now our ladder grows. Now our ladder is not this. Our ladder is that. Okay, so suppose you want to reach 20. Before that, you have to reach 15 first. For 20, you have to reach, you want to take minimum between 10 and 15. So you need to know what is the minimum way to reach 15 and 10, or for 15 you will need to know the minimum ways to reach 10 and 15. So okay, so to reach 15, the minimum way is 15 only. Why? Because we can directly see, if I want to reach 15, suppose you are here, you want to reach that one index. So will you go from the zero index? Will you ever want to go from the zero index? Fine, because you will have to pay this rent as well. Then you will go to here and you will pay this rent. So why will you do that? So we will not do this. We will directly go to 15 if we want to go to 15. So minimum cost to go to 15 is 15 only. One index is 15. Minimum cost to go to this index is 10 only. Okay. Now I want to go to 20. So minimum cost to go to 20 is max dot min of both. What is the minimum? 10 is the minimum. Plus cost of 20. Yes. Plus cost of 20. Okay. This is the minimum cost to go to 20. And see, now this is the minimum cost to go to 20, but I am at here third index. I want to go at this third index. So minimum cost to go to this third index is minimum of 15 and minimum of 20. Minimum cost to go to 15 and minimum cost to go to 20. Okay, this is my minimum. So minimum cost to go to 15 was 15 only. 15 only. And minimum cost to go to this 20 is 30. We have calculated. Go to 30 is 30. So what is our minimum? 15 is our minimum. So 15 is our answer. See, you will find on YouTube, on other channel, you will find many solution using iteration, and that is a good approach. But recursion, for understanding this question, DP is really important, and for understanding this DP, you really need to know this recursion. So see this. And now shall I make my test case complicated? So 10, 15, uh, 20, or let's take 5, 8, uh, at last 12 only. Yes, suppose our ladder is this. Okay, so see, for first case this is the minimum. Okay, for second case this is the minimum. So our recursion is like this. For first case this is minimum. For 20, what is the minimum path? For 20, if I calculate minimum of these both, 10 is the minimum plus 20. For this 20, 30 is the minimum path. 30 is the minimum path. For this 5, what is the minimum path? Minimum path for this 15 was 15 only. 15 comma 30 plus 5. Okay, so 15 comma 30, which is the minimum in 15 comma 30? 15 is minimum plus 5, 20. So for this 5, minimum path is 20. For this 8, minimum path is what? Minimum between 20 and 30. 20 is minimum. Minimum path is 28. And now let's see, if you want to reach 8, how will you reach it? So I would like to start with see, my answer is 28. If I want to reach 8, minimum path is 28. So how would I like to reach it? I will first go to this 15 index, then I will go to this 5 index. So 15 plus 5 is 20, and then I'll go to this 8. Yes, suppose if you want to reach 12, take minimum out of these both. 20 plus 32 plus 12 means 32. Yes, so if I want to go to 12, I will go like here. Yes, I'll go like here. So see, if you want to go to 12, I will go like here. Have I? Because see, uh, 28 plus 12. 28 plus 12 is what? Oh no, it is increasing. So if I want to go to 12, how would I go? So I'll first go to 15, then go to 5, and then go to directly 12. Okay, 20 plus 12, that is 32. So this is how we will approach this. So let me write the code first. So now what will I do? I will create a separate function for this. See, in other language like Python, you can directly write a nested function that will work, but in C it will not work. That's why. So uh, int this is my function min climb climb. Yes. Oh, so what will this function have as a parameter? So we are passing index of last. See, last index ladder. Last index ladder is what? Array dot length 3. So I will pass uh, return arr. Oh wait. Main client. I will pass arr dot size, or this is not arr. This is cost dot size. Okay, and we will pass cost as well, because we have to check each cost. Yes. That's all. So I have passed cost dot size, so I will get it like this: int n, comma. We are passing a vector, so vctor int type vector. Yes, this is the int type vector. So before making, I would like to make unordered underscore map. Why? Because I am using DP. Yes, int comma int. It will have int type values. See, nobody will tell you this recursion properly, and this is the way which I discovered. You can find any another way on YouTube that will also be fine. Okay, so there are many ways to write same code. Yes, that's all. So this is our DP object, and what will I do? If cost see, if n is equals to 0, just return what? Uh, Return cost of I, cost of n. Yes, cost of n. If I am at 0 index, I will have to pay that index. Yes, I will have to pay the value at that index. If cost, uh, not cost, sorry, I'm messing with this code. If n is equals to 1, return cost of 1. Why cost of 1? Because if you are at one index, you would never like to go like this. This is first from 1 and then to 2. Okay, suppose this is second ladder. So you will not like to go like this. First climb first ladder and then second. You will directly jump to second ladder. That will reduce your cost. That's why. So second ladder is this. And if, see, for each ladder we were doing minimum plus this amount. Suppose I want to climb the second ladder, we were taking minimum of these both, which was 10, plus this amount plus 20. But for last index we will not do this, we will just take minimum of these, which was 15. Yes, so if this is our again, we have three base case here. Maybe my method has three base case, you can find any other method that will only have few base cases. Cost dot size, if it is equals to cost dot size, just return what? Return ret urn, sorry, again return max min climb with what? N minus 1. Yes, n minus 1, comma min climb with n minus 2. Okay, and see, we have to take math dot minimum of it. So min, in JavaScript we call it math dot minimum, but in C you will like to use you would like to use minimum only, because it is the function. So for using this function, I'll have to include 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 what? Bits. Yes, bits slash std c plus plus. Yes, we have to do it always in cpp. Hash include, sorry, hash include, yes, and using, write it using name space uh, std yes, perfect. So till now I think I'm writing it correctly. So let's see, what shall I do? See, your function is taking two parameter, vector of int, and I should give some vector name, cost only. Okay, vector and n, so you cannot directly just pass it like this. And cost cust, we are just passing cost, we are not changing it. We don't want to change any cost or cost array, and we just want to pass it. Okay, so till now we are doing this. And now let's see, if this happens, do this. Now you just want to change, if my dp has, or how can I check? Dp dot find what? N. Suppose if I find dp dot n is equals to dp dot end. Yes, dp dot n. If dp dot find is equals to dp dot n, then what does that mean? Our object, dp object, does not have anything. Our map, I'm basically saying this map to as an object, but our dp map doesn't have anything. Then I have to fill that dp of n is equals to, suppose see, the answer for this 15 will always remain same. Okay, answer for that index will always remain same, no matter how many recursion calls you are making. So minimum amount for climbing to that index will always remain same. That's why dp of n is equals to what? Dp of n is equals to, again, same recursion. minimum of see minimum of this. Okay, I'm taking plus cost of n. Yes, perfect. So this calling code, I'm calling it here, okay, and I'm storing in it. Very good. It's totally right. I think up to here it is right. And otherwise just return dp of n. If you have inside your dp, just return it. Okay, return, yes. Otherwise return dp of n. So does my code have any error, syntax error or anything? dp, if dp does not have, then make that call. See, you, whenever you are trying to do it like this map, using this map, always do it like this. Store that recursion call into your map, and suppose for next iteration, if your map has that value, that index, it will just return. It will not go into this code. It will not fall into this code. So we are using for if statement here in this question, but it will work perfectly fine, I think. And now we are returning this cost dot line. So okay, shall I run it? Let's see. I'm not sure that this will run or not. Okay, bits std c plus file not found, hash include. Okay, let's see. Okay, why this error? Min climb. Wait. Hash include include. Wait. Is this a file not found? Why this is saying that? Uh, wait. Let me see. Am I doing anything wrong? Now that map we are making intent dp. Okay. Okay. Min climbing cost. Vector of that cost. I'm passing that vector, or cost dot size. We are passing, yes, cost dot size. That is perfectly fine. And dp of n. We are returning like this. Cost dot size. So I think this is correct. Bits. Wait. Shall I use like wait. Using namespace std hash include dot h. Wait. Oh, I forgot this. Sorry. Like I said, I never use cpp that much. That's why that happened. Okay. So see. This is running and this code is running perfectly fine. So this is a valid DP code, and its time complexity is also O of n. Otherwise, see, if your time complexity of your code is not O of n, this question will give you time limit exceeded error. See, this code is running in 95 millisecond, but it is a good code. Okay, so thank you so much. That was my approach for this code, and you can find any other approach that will be good. Okay, thank you so much.